Hi, I'm Todd Austin, and this is a short video on privacy-enhanced surveillance. I'm a professor at University of Michigan, and I'm also co-founder of Agita Labs, which is a company that makes the TrustForge product, which is the privacy-enhanced computation framework I'll be using to show this demo. Let's get started. Privacy-enhanced surveillance is an application where we want to take a video of a space and we want to know what's happening in that space, but we don't want to reveal to the vendor, perhaps, of the camera or the video service what is happening in that space. Let me give you an example. Let's say you have a internet camera in your backyard, and it's trained on your backyard, and you want to know when people are in your backyard. So the camera takes a video of the backyard, sends the video up to the servers that are owned by the vendor that supplies the camera. You pay a service. For that service, they run typically some kind of analysis on the video, where the video goes into like a convolutional neural net or whatever, and then they basically try to recognize what's happening in the space that's being analyzed. So in this particular case, we want to know if there's a person in my backyard, is it a resident or somebody that we don't recognize, an intruder, or maybe there's an animal, or maybe there's nothing happening in my backyard. So vision analysis and object recognition can easily figure this out. And then based on that, they're going to send that information back to us. And if it's just a resident or nobody in my backyard, then my app will say, hey, nothing happening that you don't need to know about. The challenge here is, the security of that server. If somebody hacks into that server, they can essentially see your video, because in order for the server to analyze the video, it needs to decrypt the video, and so the video is available. Additionally, whoever operates that server, if they have super user privilege, can definitely come in and look at what's happening on that server. Because the way systems work today, if it's not a TrustForge system, it needs to operate on decrypted data, so there's keys to decrypt that information, and the frames of the video are available for people to look at. How do you prevent someone from looking at the video coming from the camera in your home? In today's world, short of applying technologies like TrustForge, there's really no way to stop it. It's simply the will of the company to not look at that information that you have to rely upon. And that's a lot of trust you have to put into these companies. Certainly not the level of trust that I can stomach. But with TrustForge, we can actually do something quite a bit different. We can encrypt the video at the camera and then send an encrypted image. And an encrypted image looks just like, it just looks like white noise, because there's essentially no information in the encrypted data. Give it to the server, where it'll run TrustForge encrypted computation directly on the encrypted data, running the proprietary algorithms that they have already developed for this particular application, but then producing a classification on the objects in the backyard that it itself is also encrypted. And that's not by choice. That's simply the only way that TrustForge operates. When you do encrypted computation, the results of all that computation is encrypted. We've simply given them the ability to compute on this data and to send us the results back. Additionally, TrustForge provides us the ability to see if someone's manipulated the data. And if it hasn't been manipulated, if the computation to see if we have a resident, intruder, or animal in our backyard was unimpaired, then we can do what's called a safe data release. They can decrypt that value, that single piece of information, what's in the backyard, and they can send you a text or update your app, or they can even just send the encrypted value back to you for you to decrypt. But if it's, let's say there's an intruder and they want to send you a text message, that's possible with this safe data release mechanism. Now, if somebody hacks into a TrustForge server, or if a IT staff member goes rogue and decides they want to look at your data, again, all they can see are these encrypted images. They can't see what's happening in your backyard. They cannot see what's the classification of the information based on the encrypted frames that are coming up to the server. They can't see any of that because of the strong cryptography that TrustForge maintains. Well, what they can do is they can manipulate that computation. They can just say, oh, if there is an intruder, I'm gonna indicate that there's not an intruder because I'm working with this person to go into your backyard. But what happens then is the TrustForge integrity checking mechanisms detect that the computation for analyzing the objects in the backyard was compromised, and therefore safe data release is no longer possible. So it simply cannot tell you anything about the backyard when that computation's been impaired in any way. So that's a really powerful system that allows us to get a computational server from the camera vendor without having to trust the camera vendor to not look at what's happening in our home spaces. They simply cannot look because of the cryptographic strength defenses that TrustForge implements. So let me just talk really briefly about what is TrustForge and how it does this. TrustForge is a product. It's made by Agita Labs, a company I co-founded in Ann Arbor, Michigan. And it makes a secure computation framework, which is really a next-generation security and privacy platform. It enhances the Xeons in the Azure and AWS cloud to perform encrypted computation on data with permission from the data owners. And if you run a piece of computation that you agree upon with the data owner can be seen, you can do a safe data release. All the defenses of what can be seen and what information can be released safely, that is all maintained by strong cryptographic defenses. So to break those defenses, it's not about hacking into the system. It's not about bribing the operators of the system. It's not about breaking the system in any way. It's about simply guessing very large keys. It's available today on Azure and AWS, programmable in C++, JavaScript, or Python, and integrates with a number of leading databases and web UIs. We've worked with our partners to do world-class security validation, both formal verification as well as commercial red teaming. And in the 2 years we've been undergoing these efforts, we have revealed no vulnerabilities in the TrustForge platform. And the reason why I'm doing this video series is really to demonstrate that TrustForge is really the Swiss Army knife of privacy-oriented programming, because it can really span across so many different genres of programming applications, where many of these applications need a level of privacy and security that today's patch-based world can't really handle. So definitely check out the rest of this video series to see some more of these applications. All right, so that's the setup. Let's take a look at the TrustForge demo, which is going to do object recognition within encrypted images. All right, let's take a look at a demo. I'm running TrustForge on Linux, and the first thing I'm going to do is I'm just going to show you what I'm going to search for in the images. I'm not going to search for faces and such. I don't have quite that level of complexity in my demo, but I'm going to search for something a little bit simpler to find. I'm going to search for barcodes. So if I see a barcode in the image, I'm going to indicate that the object was found. So that's the object I'm searching for, and it's the order of these, the order and size of these lines that indicate whether or not it's a valid barcode. So let's take a look at the demo. I'm going to run the demo. First, I'm going to build my application, and then I'm going to take this great looking picture of University of Michigan North Campus. I'm sitting right here, in fact, and what the image pipeline is going to do is, first thing it's going to do is it's going to monochrome the image, because it doesn't need a lot of feature detail. It doesn't need color detail to find those barcodes. And then I'm going to give this image to the application, but the image is going to be delivered to a TrustForge application, so the image itself is going to be encrypted, and it's in fact going to look like this. This is the encrypted image. And you can tell by this gray noise here, there's really no information inside that image, just pure random bits. Now, the TrustForge Enclave can get access to the data and do the computation, but the software cannot see the data. All right, so let's run this on this encrypted image, and it's going to open the contract to the data. It's going to load the image. It's going to search for the barcode, and it's going to indicate the barcode was not found as we expected. Now, it doesn't tell you what the barcode is. The application doesn't release that information. It just releases the single bit of, is there a barcode in this image? And that information was released, and it was false. There is no barcode. Okay, now we're going to just add a barcode to this monochrome image here, and we're going to send it back into the TrustForge encrypted. And TrustForge is going to analyze it and says, oh yeah, I have found your barcode in the image. It doesn't know where the barcode is. It doesn't know what the barcode says. It doesn't know what the image is that the barcode is in. It just knows that this is an image, and inside there's a barcode. Single bit of information. Here's another demo. I love this picture. My favorite part, of course, is the smile on this guy's face. I don't know why that would happen, but he's running with the bulls. So again, we're going to take this image, convert it to black and white, monochrome. Then we're going to encrypt it. We're going to give it to TrustForge. TrustForge is going to analyze it. In this case, there is no barcode. So the algorithm returns no barcode found. Then we're going to insert a barcode. This is a bit of a ratty barcode here. It's pretty ratty, but the algorithm to recognize it is pretty robust. It's going to find it. So we're going to give this image encrypted to TrustForge, and TrustForge is going to run and say, oh, let's see, is there a barcode? Yes, the barcode is found in this image. All right, now I want to do just one other little demo. I want to do a supply chain attack where what I want to do is I want to alert that there's an intruder, or that the object is found in the image when it's actually not there. So I'm gonna alert someone when I shouldn't be alerting them. Like if it's surveillance, someone's in your backyard, but no one's in your backyard. So what I'm going to do is I'm going to modify the code. I'm going to come here, and in this application, ultimately it's trying to figure out if it found a barcode. So that's initially false. So I'm going to change that to true, so that this thing is going to. My intention as a supply chain attacker is I want every one of these images analyzed to indicate that there's an intruder. There's the object we're searching for. The intruder is in the backyard. So now I'm going to run that analysis, and again, it's on this image. So there is no barcode in this image. It's going to be encrypted and given to the TrustForge server. The TrustForge server analyzes it, and it says, oh yeah, the computation you ran on this image. So we did do barcode analysis on this image, but the computation you ran is not the computation that you have a data grant for. So the integrity checking mechanisms are going to say, no, I can't even tell you what happened on this, even though we did that computation. I can't reveal it to you. And in fact, until I come back here and change the code back to the way it was, where the default is false, and then I'm trying to prove with encrypted computation that something was necessarily there. Until I do that, I can't even see that if there was anything on there. So now I fixed the code, I changed it back. I'm again running on this image encrypted. There is no barcode on this image. When I run the TrustForge server on it, it comes back and says, yeah, there is no data on. There's no barcode found on this. Great. So, the key point to remember here is this framework has the ability to analyze these images as they're encrypted, so that whoever's operating the analysis system cannot see the data that is being analyzed. They can only see the information that is permitted to be released by the safe data releases. And in this case, if we change the code in any way, the safe data releases no longer function. So pretty flexible system. I hope you enjoyed that demo. It was a lot of fun to build. I really enjoyed programming. Learned a lot about barcodes. That's for sure. Okay, so to learn more about me, in fact, go to my LinkedIn page. The link is on this sheet here, on this slide. And people ask me, hey, can I get the source code to your demos that you've been doing in this video series? I'm going to release them all as part of the VIP benchmark suite. This is a collection of benchmarks that are privacy-oriented applications used for benchmarking different kinds of secure computation frameworks like sequestered encryption, which is a technology that TrustForge uses, or homomorphic encryption or multi-party computation. And then to learn more about just secure computation in general, you can go to this third link here and see a class I taught last semester at University of Michigan on privacy-enhanced technologies, and there's a lot of material there about what is secure computation. All the slides are up on that site. And then to learn more about TrustForge, just reach out to gtalabs.com, and we'd be happy to hook you up with a demo to try it out and teach you more about how TrustForge might be able to solve your privacy-oriented programming problems. Thank you so much for your time, and check out the rest of the videos in this series, and I'll see you soon. Take care.